Alright, so today we are going to show you some of the functions that are within R that will help you to do some of the survivor analysis that we have discussed in the earlier lecture. So for explaining some of these concepts and the functionality within the survival package, we are going to use the long dataset from the survival package, and in that long dataset we have survival time in days. We have the status, which is basically the censoring status, where 1 equals censored and 2 equal to death or the event. And there are some other covariates in this particular analysis. And if you just try to take a look at the head of the long dataset, you can see the covariate value. This is the survival time, this is the status, and these are all of the other covariate values. Alright, so next we already talked about censoring. Censoring is when a subject leaves the study without experiencing the event. It doesn't mean that the subject will automatically leave. It can happen that the subject might be withdrawn by the doctor or maybe lost to follow-up, and depending on the type of censoring, as we have talked in the lecture, that our censoring could be left censored, right censored, as well as it can be interval censored. So these are some of the notations that are commonly used within the survival analysis, where these notations are then used to define the survival function, which is basically the probability that an individual will survive more than time t. And if we are trying to estimate this survival function or the survival probability in R, basically first we need to define the survival object, and to define the survival object we need to specify the time element, the survival time element, and the censoring status element. And by using the surv function, we can basically see some numbers like this, where you can see 306 is the exact survival time versus this 1010 plus. That means that this person was last observed at that time, but beyond that time what happened to that person, we do not know. Whether he or she experienced the outcome or not, we do not know. But for those numbers that are without a plus, then the person experienced the event at these times, and it could be in days, weeks, hours. So if we want to estimate the survival probabilities, the best way to do it is to use the Kaplan-Meier method to estimate the survival probabilities, and we can plot them using the Kaplan-Meier curve. So to estimate the Kaplan-Meier estimates, first we can use the surv fit function on top of the surv time status that we have just created, and we use a tilde equal to 1 to mean that there is not going to be any strata or any other covariates in here. So this F1 that we built by using this surv fit is just going to be the Kaplan-Meier estimates, and you can plot that. You could plot F1 directly, or you can have the whole function down here and plot them, and you can define the x levels and y levels in the plot, and the plot will look like this, where by default you will see not only the plots in the middle but also the confidence interval for that plot. You can also try to group the Kaplan-Meier curves by sex or one particular variable. In this example, what we are seeing is that when we are stratifying by age, we will find two survival curves. One is for the male and one is for the female. And but in this plot we do not really know which one is for male and which one is for female, so it is probably a very good idea to assign the legend so that we exactly know which curve is for what. So in here we can see that sex code equal to 1 is for the black line and sex code equal to 2 is for the red line, and then we can have a good idea about how to compare, and after comparison what are the results. Alright, we also talked about median servable time, and that we can easily get using this same surfeit, where you will get a median estimate as well as the confidence interval associated with that. So besides the plot, we probably want to know how does these servable times between the two groups are in comparison, whether they are different or not. So we have the same serve and the stratifying variable is still sex, but we are now using this serve diff to get that comparison, and what this will do is this will give you a chi-square type of test with the p-values, and given by this p-value, since this p-value is small, we can say that our servable time that we are observing here are depending on sex. That means that sex variable is associated with the servable. That means depending on whether you are male or female, your servable times are associated with that. Alright, so in the original lecture we also talked about the Cox proportional hazard model, and in this case, if we are simply trying to estimate the hazard ratio from the Cox proportional hazard model, what we need to do is this form is again the same serve, time and status, which is essentially talking about the outcome, and this is basically a covariate in here, and we are using this Cox pH function to get our estimates, and we can get those estimates directly by using the summary of fit, and it will give you the coefficients and the beta coefficients. But again, if you use the publish function from the publish package, you can directly get the hazard ratio for the sex variable. Not only one variable only, you can also try to add as many variables as you need to adjust, and that will give you all of the odds ratios associated with all of the variables that you have adjusted. There are some formatting packages, say for example Broom package is very helpful to format some of the results that we obtain from the Cox pH function. Say for example publish package we have already seen, and this gives us the hazard ratio directly, but you can also use the Broom package where exp equal to true. That will also give you the hazard ratios in the same way, and you can also control for the digits, and you can also plot the hazard ratios that you get in a very nice way using this ServMiner package. This package is built on the ggplot terminologies, so you are basically using this ggforest function to get a nice plot like this. Here we are talking about the hazard ratios and the hazard functions, and in the original lecture we also talked about the proportional hazards assumption, and we talked about the need for checking or assessing the proportional hazard assumption. So in a servable analysis, we can use this Cox ZPH function to check or assess this proportionality hazard function assumption. So in here you can see that sex variable is associated with a p-value greater than 0.05. That means that there is no evidence that proportionality assumption is being violated. Also, we can graphically plot the Schoenfeld residual with respect to time, and if the proportional assumption was not violated, then we generally expect a constant line in here. So we are basically plotting the Schoenfeld residual against the time, and we are seeing that the line that we are seeing in the middle is not wildly varying, and we can also see the p-value from the Cox ZPH test is not significant. So that does not give us any evidence that there was any violation of the proportionality hazard assumption. Alright, if proportionality assumption was violated, one of the ways we can deal with the non-proportionality is the stratification that we have discussed in the original lecture. But there is another way where we can essentially use the time-dependent covariate in the Cox model. So to accommodate the time-dependent covariate in the Cox model, we need to change the structure of the dataset a bit. Where remember, in the original Cox model, what we did is that our outcome was time and status, but we do not really specify the start time, because the start time is the beginning of the follow-up that was given. But when we are dealing with the time-dependent covariate type of scenario, then we want to talk about what is happening in the first interval. So this is the first interval, this is the first interval's end time, and what happened in the first interval, and then we talk about what happened in the second interval. This is the start of the second interval, and this is the end of the second interval, and what happened during the second interval. So at each interval we try to see whether there was an event or not, and that is how we basically structured the data, where within the serve we specify what is the start time and stop time and what happened during that event. So instead of only the time, we are now talking about time splitted. So for each person we may have multiple rows, right? So for example, for this person started at 1. Say for example, from 1 week to 2 week there was an event, from 2 week to 3 week there was another event, from 5 week to 6 week there was another event. And so in the Cox model we are now again using the serve function, but this time we are having two different measurements of time. So at each interval we are talking about at the beginning of the interval time, the end of the interval time, and what happened during that interval, whether there was any event or not. And this process is known as the counting process for the Cox regression. And using this counting process we can again get the hazard ratios, and the interpretation is now with respect to the person time. And using the published package, again you can convert the hazard ratios directly. You do not have to see the beta coefficient. Alright, so the last part of this lab is basically about the survivable analysis in complex survey data. So this is a data set. I think this is the data set from Enhanced 1999, and from that data set we have this PSU variable, the strata variable, and the MEC weight variable, and there were some other measurements of time, the mortality status, and there were some covariates. And in here, when we try to take a look at the first 30 dataset, there were some missing values, but there were some censored values as well. This 90 plus was a censored variable. This 16 was not a censored variable, by the way. So this was an observed event. And we noticed that there was 0 weights assigned in this make weight. So just to avoid with the problems associated with 0 weight, we assign a very small weight, and that will make some of the problems associated with survey package uses that will make them go away. And we can also try to see whether there was any missing values, and we can see that especially for the mortality status and the two time variables, we had some missing observations. So basically this mortality status is the final mortality status or the event. We have the one variable that was giving us the person month of follow-up from the MEC or the home exam date, and there was another alternative time that was giving us the person month follow-up from the interview date. So basically we are going to use this examination data, so we are going to use this time point and this status. There was some missing values as we have seen here, so we are trying to deal with the missing data by using a complete case analysis for sake of simplicity in here. But if we are just subsetting the data set, that will create some problem in the variance calculation, so we are subsetting the design instead, whereas the design was created using the entire data. So once we created the design, so this W design is our design now, we can simply use the SVY-KM function to get the Kaplan-Meier plot, and if instead of 1 you can give one variable such as female, that will give you the stratified version of the Kaplan-Meier. You can also use the survey Cox PH function, where you are giving the time and the event, and you are also having some covariates that will give you the hazard ratios directly. And remember, this is coming from design, so these results are going to be suitable for the target population of the entire US population from 1999. Remember, we also talked about this Cox ZPH function, and but that function was previously used for Cox PH, but now we have used this survey Cox PH, right? But good news is that this Cox ZPH function also works with this survey Cox PH function, and you can see none of these observations are associated with none of these covariates are associated with p-values that are less than 0.05, and you can see the Schoenfeld residuals plotted against the time, and you can see in all of the cases the proportionality assumption, there is no clear evidence that the proportionality assumption was violated.